Hi guys, I'm Marcus S. Adenjion. Welcome back to SM Academy. Today we'll be solving a calculus question with calculus study in math courses math 302. The topic is complex number. We have this question that says if A is equal to cos 2 power 7 plus r sin 2 power 7, found the quadratic equation whose roots are alpha equal a plus a squared plus a to the 4th power, beta equal a cubed plus a to the 5th power plus a to the 6th power. So we take our solution to this. So we have, let's take the condition. Condition say if a is equal to cos 2 pi over 7 plus r sin 2 pi over 7. So if you can remember, either equation says that the relationship between an exponential equation with that of a quadratic or that of a trigonometric equation we use is called Euler's formula. So Euler's formula says e raised to r theta should be equal to cos theta plus r sin theta. So we use this Euler formula to find our value of a. So we know that a is not equal to the value of this, which is cos 2 pi over 7 plus r sin 2 pi over 7, which means theta here is 2 pi over 7. So if theta is 2 pi over 7, it means we'll have e raised to 2 pi. So we'll have e raised to 2 pi to give cos 2 pi over 7 plus r sin 2 pi over 7. So cos 2 pi over 7 plus r sin 2 pi over 7 now is equal to e raised to r 2 pi over 7. But we have this as a fractional root, so we take the 7 on both sides. So the raise this guy to the 7 power, we raise this guy to the 7 power. So the rules of exponential says that any power raised to another power, we multiply the power. So we'll have a raised to the 7 power should be equal to e raised to r 2 pi over 7 multiplied by 7. So 7 cancel 7, we'll have a raised to the 7 power should be equal to e raised to r 2 pi. So we'll have this as an equation. So we can still come back to our Euler formula that says e raised to r theta equal to cos theta plus r sin theta. So a raised to the 7 power now equal to cos 2 pi plus r sin 2 pi. In terms of radian degree, this is the radian direction. So in terms of degree, power is 180. So 2 times 180 we'll have is 360. So we'll have e to the 7 power equal to cos of 360 is 1 plus sin of 360 is 0. So we'll have 0r. So now a raised to the 7 power is equal to 0. Sorry, a raised to the 7 power is equal to 1. So this is our main ball. Look at the question. The question says, find the quadratic equation whose roots are. So looking at the quadratic equation, we know our quadratic equation is in the form of ax squared plus bx plus c should be equal to 0. So if the root of the quadratic equation, assuming we say x is one of the root which is equal to alpha, mean that x minus alpha should be equal to 0. If our second root is beta, it means that x is equal to beta, then x minus beta should be equal to 0. So if we multiply these two roots, mean we have x multiplied by alpha, x minus alpha multiplied by x minus beta is equal to 0. So if we multiply, we have x times x is x squared. The x times this is minus beta x, and this time this is minus alpha x. So if you multiply this and this negative times negative, we have positive. Alpha beta should be equal to 0. So the value of x is common. So if you factor x, we will have x squared minus alpha plus beta should be x plus alpha beta should be equal to 0. So meaning that the sum of the root is the x term and the product of the root is the constant term. We form our quadratic equation to be x squared minus alpha plus beta x plus alpha times beta is equal to 0. So we are saying that the sum of the root is always multiplied by the linear term and the product of the root is the constant term. So from the question said that the first root is alpha is equal to a plus a squared plus a to the 4th power. And the second root is beta is a to the 3rd power, a to the 5th power plus a to the 6th power. So we have division in there. So we have to find the sum of the root and also have to find the product of the root in terms of a. So first find the sum of the root. Realize that alpha plus beta is now equal to the value of alpha is a plus a squared plus a to the 4th power plus the value of beta is a to the 3rd power plus a to the 5th power plus a to the 6th power. So we rearrange them in terms of increasing power. So we start at 1 and we end at 6. The power 1, we end at 6. So alpha plus beta is now a plus a squared plus a to the 3rd power plus a to the 4th power plus a to the 5th power plus a to the 6th power. So this is the value of alpha plus beta. So now we move to the product. So we found the product by multiplying the value of alpha multiplied by beta. We have alpha multiplied by beta. The value of alpha is a plus a squared plus a to the 4th power multiplied by the value of beta is a cubed plus a to the 5th power plus a to the 6th power. So we multiply this trinomial by this trinomial. But we just treat it in question. So we multiply the first term by this. So we have a times a to the 3rd power. Remember, if you multiply or exponential over the same base, you take one base and add the power. So if we multiply a by a to the 3rd power, we'll have a to the 1 plus 3 is 4, a to the 4th power. So we also multiply this by this, we'll have a to the 6th power because 1 plus 5 is 6. If we multiply this by this, we'll have a to the 7th power. So 1 to a squared. So a squared times a to the 3rd power is a to the 5th power. And a squared times a to the 5th power is a to the 7th power. The next is a squared times a to the 6th power is a to the 8th power because 2 plus 6 is 8 plus come to a to the 4th power. So a to the 4th power times a to the 3rd power is a to the 7th power. So a to the 4th power times this is a to the 9th power. And a to the 4th power times this is a to the 10th power. So we can add common variable and we arrange them in terms of increasing power. So the least power we have here is a to the fourth power. So we have a to the fourth power plus a to the fifth power. The next is a to the sixth power plus a to the sixth power. So we have a to the seventh power, which is one a to the seventh power, another a to the seventh power, another a to the seventh power. Because of the same variable, so we add the coefficients of this. So we add 1 plus 1 plus 1. We have 3 a to the 7th power. The next is a to the 8th power. So it's a to the 8th power plus a to the 9th power plus a to the 10th power. Remember we said that a to the 7th power is equal to 1. So we can reduce a to the 8th power to a to the 7th power. We can also reduce a to the 9th power to a to the 7th power. And we reduce a to the 10th power to that of a to the 7th power. We say a to the 7th power is equal to 1. So a to the 8th power is equal to a to the 7th power multiplied by a. So if a to the 7th power is 1, as we said up here, so if 1 times a will have a to the 8th power to be equal to a. And also a to the 9th power is a to the 7th power multiplied by a. So we have a to the 9th power to be equal to a to the 7th power is 1. So 1 multiplied by a squared will have a squared because 7 and 2 will give me 9. So it means a to the 9th power 9 is what? Is a squared. And a to the 8th power 9 is 8. So move to a to the 10th power. So a to the 10th power is, remember 10 from 7 you will have a to the 7 multiplied by a to the third. So a to the 10th power will be equal to a to the 7 is 1. So 1 multiplied by a to the 10th power is a to the 10th power. Meanwhile, a to the 8th power is now a. And a to the 9th power is now a squared. And a to the 10th power is now a to the 10th power. And a to the 7th power is 1. So my new equation, which is alpha multiplied by beta, is equal to, we have a to the 9th power. So move a to the 4th power plus a to the 5th power plus a to the 6th power. As we said, a to the 7th power is 1. So we have plus 3. 3 and 1 is just 3. So it's a to the 8th power now is what? Is a. So we have plus a. And we have a to the 9th power now is what? Is a squared. So plus a squared. And a to the 10th power is a to the 10th power. Is a to the 10th power. So my alpha multiplied by beta will have my equation in terms of increasing power. We'll have a plus a squared plus e to the 10th power plus a to the 4th power plus a to the 5th power plus a to the 6th power plus 3. So if we realize that this graph, this value of alpha and beta, and also the product root, my sum of the root with alpha plus beta is this. So we use this to find our quadratic equation. One thing to remember here is looking at the power, have 1, 2, 3, 4, 5. So the power is in terms of increasing function with the same value of a. So we can take this as our geometric progression. So looking at the geometric progression, we said that a geometric series is a series such that we have the summation of the value from k to 0 to the value n, where k, we have a raised to r of k should be equal to a parenthesis will be 1 minus r raised to n plus 1, all divided by 1 minus r, where r is not equal to 1. Because r equal to 1, we'll have our undefined solution. How we formed previously, we said that the sum of the root is a squared, a to the third power, plus a to the fourth power, plus a to the fifth power, and plus a to the sixth power. And we said that the product of the root is a plus a squared plus a to the third power plus a to the fourth power plus a to the fifth plus a to the sixth plus 3. Because we have continuation in terms of power, which means move from 1, we go 2, we go 3, we go 4, we go 6. So we classify this as a geometric series, where we say the geometric series is the summation of k as k moves to 0 to n of a of r raised to k should be equal to a parenthesis will be 1 minus r raised to n plus 1 divided by 1 minus r, where r is the common ratio and n is a normal position, or we call it a term position. So we can find a series. So we have a. First, we have to find the value of r, which is the common ratio. In terms of geometric series or sequence, we said that the value of r, which is the common ratio, is the second term, u2, divided by the first term, u1. So my second term here is a squared. My first term here is what? Is a1. In any of this series, even in the sum of the series or the product of the series, the first term is what? A, and the second term is a squared. So my value of r, which is the common ratio, will be equal to a, because the rules of indices say that we have the same base in terms of division. We subtract the power, so we have 2 minus 1 will remaining 1. So the value of r is 1. So we take our sigma notation, says that a a of r raised to k. And it says that k moves to 0. So the first value is 0 plus, and r is what? A. So we have a raised to 0 plus a again multiplied by the value of k, which is r, which is a again raised to what? 1. Because sigma notation is like you adding from one point to another in terms of power, where we're moving from the value of 0 to the value of n. Because for now, we don't know the term position. So we have to find the term position in order to find this sequence from a1 with the power 1 to the power 6. So have 1 plus a parenthesis will be a raised to the second power plus a parenthesis will be a raised to the third power plus a parenthesis will be a raised to the fourth power plus a parenthesis will be a raised to what? The fifth power. Let's do this first. So we have a raised to 0 is 1. So 1 times a we have is a plus a raised to 1 is just 1. So we have a times a, we have a squared. When a raised to 2 is a squared. So a squared times a is the third power. The next one, a to the third power is a cubed. So a cubed times a is a to the fourth power. If we multiply this by this, with a to the fourth power by this, we'll have a to the fifth power. The next one is this raised to this is what? A to the fifth power multiplied by this is a to the sixth power. So we realize that the number position or the term position here is what? Is 5. So we can say because we move from k to 0 all the way to what? 5. So our number position here now is what? 5. So we have the sigma notation of k goes to 0 to 5. We got a raised to r of k should be got parenthesis will be a, parenthesis will be 1 minus r raised to n plus 1, where n now is a normal position with the term position to be 5. So we have 5 all minus 1 minus r. And we realize that where r is what? It's a common ratio, is 1. So my notation here is a parenthesis open 1 minus a. R is a. So it's a raised to what? 5 plus 1 is 6. All divided by 1 minus a. So the entire series here is the same as this. Is the same as what? This. So it means that the series of this is equivalent to what? This. So it's the same notation from k to 0 to 5 is equal to a parenthesis will be 1 minus a to the 6th power minus a minus 1 minus a. So going back to our quadratic equation, we said that x squared minus the sum of the root plus the product of the root will be equal to 0. So now my entire series up here is this. So we have x squared minus a parenthesis will be 1 minus a to the 6th power all divided by 1 minus a plus x plus, and my product series here is this. So from here all the way here is this series. So we have a parenthesis will be 1 minus a to the 6th power all divided by 1 minus a plus 3, because we have plus 3 at the end. So we can simplify, should be equal to 0. So if we simplify, we'll have x squared minus multiplied by a in parentheses, we have a minus a to the 7th power divided by 1 minus a, right, of x plus multiply again, we'll have a minus a to the 7th power all divided by 1 minus a plus 3 should be equal to 0. So from our equation, say x squared minus a to the 7th power 1 minus a multiplied by x plus a minus a to the 7th power 1 minus a plus 3 is equal to 0. So remember that previously a to the 7th power is 1. As the big use of Euler formula, we found that a to the 7th power is 1. So we have x squared minus parenthesis will be a, this guy is minus 1 minus a by x plus a to the 7th power is 1 minus a plus 3 is equal to 0. So we have an equation here. So we can factor, to cancel the denominator for this case, we can factor the numerator by negative. So we will have x squared minus parenthesis will be. So we factor by minus, we'll have positive 1 and we'll have negative a, because this time this will give me minus 1 and this will give you a positive 1. All divided by 1 minus a of x plus the same thing this side. So we have the same way. Minus parenthesis will be 1 minus a all divided by 1 minus a plus 3 is equal to 0. We have negative times negative is 1. This is positive. So we have x squared. This guy and this will cancel. So we'll have plus x. So this and this will cancel. We'll have positive and negative is negative 1 plus 3 is equal to 0. So we'll have x squared plus x. Take difference, we'll have plus 2 is equal to 0. So our quadratic equation is x squared plus x plus 2. After we have the first root to be one series, we'll have the second root to be another series, and we'll realize that our quadratic is x squared plus x plus 2 is equal to 0. Thanks for watching. Remember to like, share, and comment. See you back.